Hi. So now we're going to write some actual example problems out. I'm going to show you how to do orbital diagrams, how to draw them, and then I'm going to show you how to write electron configurations. That'll be the next video. For right now, for doing this successfully, I strongly encourage you to have a periodic table. All right, that's useful. In addition, I encourage you to print this document from the website. All right, it's really helpful. Okay, it is crazy helpful. You're going to want to reference it, trust me. So what I want to do now, I'm just going to do some examples where I show you how to do these or how I would like to do these problems. So to begin with, let's do a really simple one. Let's do fluorine. Let's write the orbital diagram for fluorine. All right. So we're going to do F here. So fluorine. Now, as far as fluorine goes, the basic idea is this. How many electrons does fluorine have? How many electrons are we going to represent fluorine with? Well, these are all neutral right now. Nothing's an ion. So we're just going to say fluorine has how many electrons? 9. How do I know that? Because the number of protons, if it's a neutral atom, is equal to the number of electrons. So in short, the atomic number here, we're going to use that. That's going to be what we use to figure out electrons. So we've got 9 for fluorine. So we're going to have 9 electrons present. So we're going to put 9 arrows in. Now we're going to do the orbital diagram. So to do this, let's look at this little chart. It's very useful. So remember, this corresponds to the periodic table. Fluorine is right there. So that's cool. We now know where fluorine is. Yay. But the point of this is that we're going to represent all of the electrons that are present in fluorine. So to start with, here's how you'll do this. You're going to basically start by saying, all right, what is my very first thing? And to make this easy, I'm going to actually show you on here so I don't have to just like completely write all over this thing. It's not going to work. So all right, so fluorine, we've said it's right here. So fluorine's right there. Maybe we can change the color. Ooh, look at all these colors. I'm colorblind, so let's just go with let's go black. I can tell it's black. It's easy to see. So fluorine's right there. And we're starting here now at 1s. All right. So the very first thing we're going to have is 1s. And then we're going to go all the way through there, still 1s. All right. So what you'll actually do here now, you're actually going to go and say, all right, I'm going to write down 1s. Now, how many sublevels, or pardon me, how many orbitals does an s sublevel have? And you're like, oh, s sublevels have 1 orbital. You're going to put 1 dash. All right, 1 dash, because the s sublevel, if you go back to your notes, the s sublevel has 1 orbital, 1 dash. Cool. So back to here now, and you're like, all right, now I'm at 2s. Now I'm at 2s. And it's just, you're treating it like it's almost like a typewriter, or like I used to say typewriter, nobody knows what a typewriter is. A Word document where it's like you go down, you go to the next line. All right, just go to the next line. So the next thing you go through, 2s, right? So back to this now, you're going to be like, all right, 2s. How many sublevels, or how many orbitals does the s sublevel have? 1 orbital again. Doesn't matter whether it's 1s or 2s. It's always 1 dash. All right. So you keep going with it now, and you're like, all right, you're gonna go over, and what's the next thing you hit? 2p, and that's where fluorine is. So that's where you're gonna stop. So you're gonna be like, okay, now I got to write down 2p. So I'm gonna say, all right, I got 2p. I'm gonna go 1, 2, 3. Why do I write 3 dashes? Because it's a p sublevel. How many orbitals does a p sublevel have? 3. Always, 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 always. All right. So, cool. Congratulations. You've now written out the configuration. Well, you've written out the orbital diagram like the basic. But now, how many arrows am I going to put in? I'm going to put in 9. So to do that, you're just going to start with 1s. And you're going to go 1. You're going to go 2. Again, I'm drawing my arrows like that. If you don't like it, too bad. It's faster. So I just put in 2 arrows, right? Okay, so that leaves me with, I'm going to actually keep like a running tally. That leaves me with 7 electrons now. I'll go 2 more. 5 electrons. Now, why am I just going 2 like this at a time? Remember the off-ball principle. You fill in the lowest energy level first, so like 1s, it's lowest, fill it up. 2s, lowest, fill it up. Yeah, pen always marks up there. It looks so nice. Now there's ink everywhere. No. But now we've got 5 electrons left, so we're going to fill in 1, 2, 3. Remember, you never double up. You never double up until you have to. So I put in 3, but I have 2 more because I got to get to 5. So I go now down the other way, 4, 5. We're left with 0 now. Congratulations, you did that. And this is your orbital diagram. So this is a orbital. This is an orbital diagram of fluorine. All right, it lets you see where stuff is. All right, that's sort of the deal. All right. If you have questions, normally this is if I used to record these in class, I'd be like, hey, all right, so what questions do we have? And people would ask questions, but no, can't do that right now because pandemic, blah, blah, blah. It's annoying. So anyway, this is good, useful. So that's one orbital diagram. Let's do a longer one now. Let's do a longer one. What's another good long one? Let's check out, let's say, we'll do 2 more. So next, let's do potassium. So let's do potassium now. It's over here. So K. So we got potassium. It's got 19 electrons. So we're going to put in 19. But first, let's figure out the actual configuration. So K is over here. So to do this, you're going to trace along again, and you're going to say, like, okay, we got 1s. So you're going to write out 1s, 1 dash. Then you're going to keep going. And you're going to go back to 2s. And you're going to be like, okay, 2s, 1 dash. Then you're going to keep going, and you're going to get to 2p. All right. 3 dashes because it's a p sublevel. Then you're going to keep going, and you're going to keep going. You're going to get down to 3s. You're going to be like, all right, 3s, 1 dash again. Then you're going to keep going, and you get to 3p. P sublevel, so 3 dashes, and then finally, you're going to get to 4s, and you're like, all right, 1 sublevel, or 1 orbital, because again, s sublevel, 1 orbital done. So now, now you have 19 electrons to fill in. All right. So there's a couple ways you can do this. The way I showed you in this other example problem, well, it was one way to do it. It wasn't the world's most efficient way. There's actually a faster way. So pretty much with everything in this class, you're going to be able to make the assumption that everything is filled in until the last sublevel. So the element, potassium, is in the 4s sublevel. All right. So let's assume that everything before there is filled in. All right. So let's just assume. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Cool. So you filled in 18. You had 19, so there's 1 left to put in. 1 left. Let's say you don't even want to count, because you might not want to count. That's fine. Look at 4s here. How many electrons can an s sublevel hold? It's 1 orbital, 1 dash, so it can hold 2 electrons max. All right, 2. How many boxes are there in 4s here? Well, there's 2. Each box represents an electron. So if K is in the first box, 1 electron. If you had the second element, which would be calcium, there'd be 2 electrons, but there's only 1, so you just put 1. It's much faster. So that's the configuration for potassium, or that's the orbital diagram for potassium. All right, and then let's keep going here. So now let's do another one. Let's do iron. Then this will be it in terms of length. Then I think then you get the idea. So now let's look at iron here. That's 26. So make sure you count correctly when you fill this in. 1, 2, 3, 4, 5, 6. It's just, it's just good practice. So you got iron. Now in this case, I'm not even going to count the electrons. I don't even care that it's 26, because all I'm going to do is fill everything in and we'll go from there. Now, one thing you're starting to probably realize is that there's a ridiculous amount of repetition here. you'll notice that like you got all this, and it's just like it's what it is. It's the same thing, and you're gonna be like, oh well, if iron's right here and potassium was right here, well, I'm gonna have everything be the same. I'm just gonna have 3D at the end of it, and that's true. So when I used to have my fancy smartboard, I would just copy this. But no, I can't copy and paste with a pen, so I gotta write everything out. So that's okay. Be patient. So we're gonna go 1s, 2s, and you'll probably want to start writing a little smaller. 2p, 3s, 3p, 4s. And then last but not least, you now have 3D. Now, D sublevel, haven't done that one yet, but 3D is 1, 2, 3, 4, 5. Again, D sublevel, 5 dashes. Okay, 5. So, you'll now say, all right, I've got that down. Remember, like I said, just fill everything in before the last sublevel. So 1, 2. You don't even have to count. And you see now why I draw my arrows like this. It's way faster. All right. So to represent all the electrons here, you're like, all right, so we got iron. And iron is, it's right here. So how many over is it in this sublevel? So you're going to go 1, 2, 3, 4, 5, 6. So you're going to put 6 electrons in this final sublevel. Now remember, you do not double up until you have to. So you put in 5, there's nowhere else. You must double up. You go put another one like that. To answer some questions that you might have, it doesn't matter. It's just traditionally the first arrow is facing up, the second arrow is facing down, and you put them all up normally, and then you put them all down. If anybody was wondering about that. That's usually a question I get. So that's the deal. That's like the orbital diagram. Now, like, what's the point of any of this? Why do we care about this? The basic idea is this. So, like, let's take a look at. I'm gonna just write these out really fast. So let's look at sodium and chlorine. Very common compound, sodium chloride, right? So you know that sodium chloride, table salt. The basic idea is this. So if you think you got sodium, its formula, like its highest energy sublevel, sodium's gonna basically, I'll just write the whole thing so you don't get confused. 1s, 2s. So that's sodium. And then chlorine over here would be 1s, 2s. 2p, 3s, 3p. This is just, I'm going to explain to you why we even care about this, because some of you are probably sitting there being like, who cares? And you're not totally wrong until you see this, and you're like, okay, so sodium and chloride, sodium and chlorine, they bond to form NaCl, table salt, one of the most common things on this planet. All right, one of the more common compounds used by everybody pretty much on the whole planet. I don't think there's a single species, or, well, I don't think there's a single bunch of people out there that have ever been like, no, screw salt, it's horrible. People are like, no, salt's important, because I mean, salt, you kind of need sodium and chlorine to live, especially chlorine, in the form of the chloride ion. But anyway, so the point is, you look here, you see how sodium, like elements like to have filled electron levels. They like to have filled shells of electrons, filled orbitals. They're more stable that way. So right now, you see how sodium has like 1 electron left? If it got 1 more, it'd be like totally filled up and it'd be like totally happy. Same with chlorine. Notice here how chlorine's got like 1 open spot. So the way it kind of works in this case, like chlorine's got this open spot right there. So what happens? Sodium pretty much says, here you go, chlorine. I'm going to give you this electron over there. And then chlorine's like, oh, dude, that's awesome. I'm now completely filled up. Like, I'm stable now. And sodium's like, well, look at me too now. Like, this whole sublevel is just gone. I'm now stable too. But then all of a sudden, sodium, like, what did sodium just do? Sodium just lost an electron. It gave away an electron. All right, when it gives away an electron, that means that it becomes positive because it gave away a negative charge. Chlorine just gained an electron, right? So when chlorine gains an electron, it becomes negative. All right, and what happens when you have a positive and a negative thing near each other? They stick together. They stick together really tightly, and you get an ionic bond. And then you have sodium chloride, and that's why we care about this stuff. All right, that's why. So I hope those examples helped. Hope they were useful.